Hello, friends. Welcome to the ATC Double Cut. In this episode, we're going to look at a couple new posts from the ATC website. We'll talk about putting green firmness. We'll talk about tournament golf, and we'll talk about variability in soil test results. We'll talk about all of those things in this episode. We'll start with a post called Green Speed Change from Morning to Afternoon. That is the title. And as usual, I will put a direct link to this post and any post that we discuss. I'll put those in the show notes so that you can check them out. You can go look at the pretty pictures. You can look at the charts. This one has both pretty pictures and charts, and you can study them and see any of the links in case you're interested in this. And for tournament golf, I think everybody involved in golf course maintenance should be interested in that, just like everybody who's involved in sports turf maintenance, I would think, is quite interested in sports turf maintenance at the very highest level for professional athletes, because that is where we can learn so much. And I've had a chance to work at many golf tournaments, and I worked at a golf tournament in May in Japan. This was the Sky RKB Ladies Classic. It was held in Fukuoka Prefecture, which is in western Japan, southwestern Japan. The greens on the course where this tournament was held are creeping bent grass. This tournament was held at Fukuoka Rizon Golf Club, and I start off by showing a picture of the 10th green at Fukuoka Rizon Golf Club. And in this post, I show my measuring tools. And one of the measuring tools that I bring when I make a standard set of measurements at golf tournaments, or I do this sometimes for everyday play, I bring a stimp meter, I bring golf balls, I bring a tape measure, I bring my golf course firmness tester or CLEG, I bring a TDR 350 for measuring soil water content, and I bring some thermometers and a wind speed. What's that called? An anemometer for measuring the wind speed, like a portable weather station. So I like to assess not only what the conditions are, but what the environment is in which the grass was growing. So I took those tools, I took them to Fukuoka Rizon Golf Club, and I made a set of measurements both before play and after play, because I like to see what the conditions are like at the start of play, and I like to see what the conditions are when the last group finishes. And that's why I gave this blog post a title of Green Speed Change from Morning to Afternoon, because I was measuring the green speed in the morning after the greens had been prepared for play, and I measured the green speed again in the afternoon after the final group had finished. And I found something very interesting, which I will discuss with you. I also put in this post a link to, and I embedded also a short video showing the Hutsta brand 500 kilogram roller. And this is a roller that is self-transporting in that it has a hydraulic system with wheels that will lower the rolling unit down so you can then roll a surface, and then you can use the hydraulic system to put the wheels back down, and it lifts the rolling unit back up, and you can drive the roller then on those wheels to the next area that will be rolled. So I put that and a couple of other interesting video clips from the tournament are in that short video. The green speed change that I measured, it averaged 0.6 inches per hour decrease. So, for example, the first day that I measured was on the Tuesday, on May the 13th, and the average green speed in the morning was 12.7 feet. I'm reporting these in decimal feet, not in feet and inches. So it was 12.7 feet. In the afternoon, the speed that I measured was 12.5 feet. Then on Wednesday, the speed I measured in the morning was 12.8 feet, and the speed I measured in the afternoon was 12.4 feet. I report this as a decrease in speed in units of inches per hour, in order to standardize this, because on some days I might have measured at a slightly different time. But I know exactly what the time was because I record that in my notebook. So I standardize everything to be inches per hour. And during this tournament, on average, from the 6 days that I measured, from Tuesday through to the final round on Sunday, the average was 0.6 inches slower every hour as we went through the day. And if you calculated that for an 8-hour time period, that would be 4.8 inches decrease from morning to afternoon. And I wrote in the blog post, I said, this is an elite decrease. Measurements I've made at other events have generally had a decrease closer to 1 inch per hour. And I don't know exactly why I measured such a small decrease, such an elite decrease. Like ideally, you'd have zero decrease. I have a couple of ideas. One is that the growth rate was well under control at this event, and the surfaces were just superb, and the surfaces were relatively firm for bent grass. And it may be that with slow growing, relatively firm surfaces that don't get too disrupted during the day, it may be that you can get that kind of elite decrease, meaning a very small decrease in green speed from morning to afternoon. But this was a ladies tournament, and I noticed something. I've worked at a lot of men's tournaments, and I haven't worked at so many ladies professional tournaments. The field size for the Sky RKB Ladies Classic for this tournament at Rizon Golf Club, the field size was 108 players. So there were 108 players plus 108 caddies, and that's it's a larger field than the Masters tournament, but it's not like a 140 or 150 person field, but it's still a relatively large field. I noticed that at the end of play, the greens looked as if they hadn't been played on. There were very few pitch marks. There were fewer visible pitch marks than I would typically see, and basically zero spike marks. And I think that the impact that the lady professional golfers had on the greens at Rizon Golf Club this week it was less of an impact than what I've seen at men's golf events on bent grass. And whether that is because of the type of footwear or the way that people walk, or the types of spikes on the shoes, or just the mass of the players combined with the shoes and then the force that exerts on the green, I don't know. But I speculate that one of the reasons for seeing this elite decrease in speed, the very small decrease in speed, may be that the players' footwear and spikes just did not disrupt the surface so much, leaving the surfaces a little bit smoother at the end of the day than they would be at a typical men's event, and then the ball can just roll farther, and thus you get less of a decrease from morning to afternoon. So again, what I've typically measured for men's events is a approximately 1 inch decrease. Well, it's not approximate, it's the average. The average value that I've measured for men's events is a 1 inch decrease per hour over the course of the day in green speed. And at Rizon, I measured 0.6 inches. So that was interesting. And there's another thing that was different at this tournament. The greens were not rolled in the morning. The greens were only mown in the morning. And in the afternoon, after I made my green speed measurements, the greens were rolled. Again, I made my measurements before the greens were rolled, but the rolling was done exclusively in the afternoon. at most of these other tournaments that I've made these measurements, the greens were mown and rolled in the morning. So there's a number of things that are different, and there's no way to pull the answer out as to what the cause of this elite decrease was. Why did the greens decrease less in speed during this event than is average? Is it because the rolling in the morning? So if you would have rolled in the morning, perhaps the speed would have been higher, but then it would have decreased over the course of the day to a larger extent. I'm not sure, but it's fun to measure these things and think about them and try to figure it out and understand more. Now, there was also some really interesting data about surface hardness or firmness and soil water content, because the greens were allowed to be relatively dry at the start of the week. It was May, high growth potential. They started off with a suitable soil water content. There was no hand watering done, and there were also no dry spots, and the greens were just getting drier and drier from Tuesday through to Friday. And then on Friday night, it rained more than 30 millimeters. By mid-morning on Saturday, I believe about 45 millimeters of rain had fallen, and that is well over 1 inch of rain. So the greens then went to field capacity for the measurements made on Saturday morning and on Saturday afternoon. So I had this track of or timeline of soil water data and also the timeline of surface hardness. And the greens lost 11.5% in firmness. So from the level that they were at on Friday afternoon, when they went from that relatively dry condition on Friday afternoon and then went to field capacity on Saturday morning, the hardness measurement in Gmax units, it decreased by 11.5%. So we could say that the greens reduced in hardness or lost 11.5% of their firmness. That is interesting, and I will get back to that with a little bit more speculation. But first, I want to point out that I have an Instagram account, and sometimes I put turfgrass photos there. I will mention, not for the first time, that John Kaminsky, the well-known photographer and professor from Penn State, told me one time that he thinks I might have the worst Instagram account ever. It's so boring because it's just grass photos. But if you're into grass photos, it might be the best Instagram account ever. So if you like grass from around the world, if you like turf tourism, if you like to see some interesting hotel lawns, and if you like to see turf equipment from around the world, then you want to check out my Asian turfgrass Instagram account. So I embedded a gallery of images in this blog post. You can also see that directly on Instagram. And I showed some of the mowing. And it's interesting, Rizon is in the foothills of, there's a mountain called Mount Rizon. And there's a lot of agricultural land that's at a lower elevation. And then Rizon comes up and sits on the foothills and on some terraces. And then the mountains go up beyond, much higher behind the golf course. But up on the golf course, you can look down and you can see all the way out to the ocean far in the distance. And you can see a lot of agricultural land and some bedroom communities as the train line comes out from Fukuoka. So I tried to capture that, the setting and the image of what this golf course looks like in these photos as I took some pictures. Mostly I was out there collecting data, but occasionally I had a chance to take a few pictures to show some of the staff. And I got a nice picture of Mr. Fuchigami, the greenkeeper at Rizon, and he's been there for a number of years. And I'm just so impressed with the work that he's done to improve the conditions out there. The mowing lines on the fairways are so much better than they used to be. The green conditions, especially the consistency of the greens through the year, are they're much better than they used to be. When I first visited there more than 10 years ago, we'd see some thin spots in the greens, especially towards the end of summer. And more recently, I've visited at the end of summer, and the conditions are much better. In fact, in the summer of 2023, I did a data collection project in Japan that extended from the other side of Tokyo all the way through central Japan and into western Japan. And one of the courses that I collected data from was this one, was from Rhizon. And as far as green speed and firmness goes, I was measuring from bentgrass greens, zoysia greens, and Bermuda grass greens. And in that data set from 19 greens, from 19 different golf courses that we collected from on that project in the middle of July, the fastest and firmest greens were at Rhizon, which is pretty impressive to do that on bent grass in July. So, and to have greens that are firmer and faster than Bermuda grass. So that was, it was fun to work at this tournament and to see the greens in such good condition and have a chance to measure those data. I will point out also that those greens, there were some follow-up questions after I published this blog post. And one of the questions was, what grass variety is there? What grass variety is it? It's creeping bentgrass. And it is a variety. It was planted originally when the course was built in the 1990s. It's a Japanese variety called Art 1. And I believe it's used only in Japan. I haven't heard of this variety used anywhere outside of Japan. And that variety was developed as a vegetative selection from Pencross. And more, let's say over the past 5 years or so, maybe I think it's been about 5 years, the greens at Rhizon have been interseeded with 007 and with 777 creeping bentgrass. And these new varieties have much better heat tolerance and low mowing tolerance than does the Art 1. And some of those areas where they were just thinning out so much in the summer, we're not seeing that so much anymore. So the greens aren't like pure 007, pure 777, but they have a lot of that seed that's been put in them over the past 5 years. And that has led, in addition to the good management, but adding that improved adding those improved bentgrass varieties also seems to have had quite a good effect. So I then wanted to add a little bit more about surface hardness and water content. And I think I think this is something that I'm going to try to remember to share more about this year, because as I think about this and I realize I have so much data on this because I've been collecting data about surface firmness since 2011. So I've now got 14 years of data, and it includes a lot of measurements from regular golf courses, and it includes measurements from tournaments. And pretty much when I measure firmness, I make a paired measurement at the same location of soil water content. I make the measurement at with a TDR 350 at the moment, and I'm using the 7.6 centimeter or 3-inch rod depth. So that's how I am measuring it. In the past, for example, I showed a chart that I made in 2012, and it's a big blob of data points from 1,193 samples that I collected in 2011 and early 2012. And it shows on the horizontal x-axis, it shows the soil water content going from a range of about 0 up to 60% by volume. And then it shows the Gmax measured by my golf course firmness tester, or CLEG, that goes in the range of about 60 up to 140, 60 being soft, 140 being quite firm. But basically, it's just a big cloud of points with a few that are really dry and really firm and a few that are really wet and really soft. But in the middle, there's just a big cloud of points. And the issue is, that's what you get if you go and collect those measurements from a whole bunch of different golf courses and a whole bunch of different grass types, because there's not a universal relationship between firmness and soil water content once you put in all of the other things that vary, like the grass type and the organic matter content and how recently the greens have been aerified, and how recently the greens have been vented and so on. Then when you do that, there's all this other variability that comes in there. But if we would break this out by golf course and break it out by individual dates, we'd start to see that there's a very consistent trend that if you have a surface that is in a particular state, and by particular state, I mean it has a specific organic matter content and it has not, or it's been aerified at a certain time. So it's in a state. We change that state by aerifying it, because when you aerify, you make it softer. And so if we have the green in a certain state, then as it gets drier, it will get firmer. As it gets wetter, as the soil gets wetter, it will get softer. That's the way that it is. And that's something that I want to try to explain, because I've had a lot of people ask questions about firmness, and I see some people try to achieve firmness by aerifying and adding sand. I once tried to do that and failed at it completely. That actually makes the greens softer. And I measured that. And I measured that so long ago, more than a decade ago, and I learned from it, and I stopped doing that. So now when I want to make the greens firmer, I say, let's stop aerifying. Let's not aerify as much, and let's stop loosening the soil. Let's let the soil get as hard as possible. And that is something that I want to try to explain so that everybody else can understand this as well as I think that I understand it myself. So this is something that I just wanted to throw that out there. And this is something that I'd especially be interested to hear from people about. If you have questions about firmness, or if you think that I misunderstand it, or if you think that it's more complicated than I'm saying that it is, I would really like to hear from you. You can contact me directly, or from this podcast, you can leave a comment on Spotify, it's easy to get in touch with me. Go to the Asian Turfgrass website, click on the About page, and you can find links to email me or contact me through many different ways. I closed this out talking about that relationship between soil water content and firmness by writing this. I've had many years to think about this, and I have collected a lot more data. A number of things seem clear to me now. The measurements, and by the measurements I mean the measurements of soil water content and measurements of firmness. Any individual measurement, it's not exact. And so by error, I just mean there's a lot of error in the measurements. But back to my quote, the measurements have a lot of error, but if we take enough of them, we can identify the relationship between surface hardness and soil water content. Higher volumetric water content leads to softer surfaces. There is no universal relationship between specific volumetric water content values and specific firmness values. For any, okay, now I'm back in real time and elaborating on that. I said that there's no universal relationship. What I mean is what I measured at Rhizon that week is not the same as what would have been measured at Augusta National during the Masters, and it's not what is being measured at the Memorial Tournament at Muirfield Village, and it's not what the POA annual greens at Oakmont will measure. But for any of those locations, for Rison, for Augusta National, for Muirfield Village, for Oakmont, or for any kind of golf course putting surface, there will be a relationship for the state that the green is in. If it gets drier, it will get firmer. But all of those different greens will have a slightly different relationship. So there's not a universal relationship that's the same. We can't say that 20% water content is going to give you this firmness level, but for your golf course, you can figure that out. But now if you come in and aerify it, that number is going to totally change. Now at 20% water content, it's going to be a lot softer than it was before you aerified it. But then if you roll it and you put more traffic on it and you mow it and you get it back to the same level of compaction that it was before the aerification, you'll get it back to where the firmness is what you predicted it would be from that 20% water content. And so for any single location and single state of the root zone and state of the soil, you will be able to have a clear relationship between the water content in the soil and the firmness of the greens. I close this out by saying there are consistent relationships for a certain soil state between specific volumetric water content values and specific firmness values. I was checking this on the greens at Rison Golf Club, and for the greens in their current state, the surface hardness goes down by about 0.9% for every 1% increase in soil water content. And then I said that this specific relationship will vary depending on the state of the green. And by state, I mean the current combination of species, season, time since the most recent cultivation event, and so on. So this is the end of this post, and I think the one thing that I will repeat, that for the state of those greens at Rison, these are creeping bentgrass greens, the surface hardness goes down by about 0.9% for every 1% increase in soil water content. And that is something that is good to know, that those are related. I guess I would just elaborate a little bit more and say that the soil water content is a lot easier to manage if you have the organic matter of the root zone under control. So if you have too much organic matter in the root zone, then when it rains, you're going to have too much water. Or if you add irrigation, you're going to hold too much water in the root zone, and the root zone is going to be softer than it would be with less organic matter content in it. And that's where there's a connection with soil organic matter. And specifically, we don't really want to measure the soil organic matter. We want to measure the total organic material in this case, or what I call OM246. If you track your OM246 measurements, you're able to see what the total organic material is right at the surface of the root zone, and that's going to have a huge impact on your infiltration rate, on your grass, at your surface firmness level, and on the amount of water holding that you're going to have right near the surface. So that is really what has an effect is the water holding content or the water in the soil, but the organic matter that is there has an effect on the water. So that is something that I've talked about before, and I will continue to try to explain this more clearly so that everybody understands it. I wrote a post yesterday that we can talk about now. This one has a title, "The Geometric Mean as the Central Tendency or Average for Soil Nutrient Data." This one I will mention that I wanted to make a blog post yesterday that had a lot of charts in it because I wanted to check something about the display of the blog email that goes out. The blog email for the past few years has been sending images that are low resolution. So the images in the email that goes out are relatively low resolution, and for charts in particular, they have a gray background, and that's related to the image optimization software that I'm using for the blog to reduce the file sizes so that everything will load more quickly, so that websites will load more quickly, and so that emails are not too big, and it won't take too long to download the email or to load the website. The problem is I would rather have people wait just a little bit to get the image downloaded in order to get a higher quality image. And so I was doing some checks to figure out how to do that, and I think that I figured that out yesterday. So I said, let me do a blog post to make sure that these charts send properly and are clear in the email. And I had one in my blog post to write file about some interesting soil test data from a golf course in Japan from samples that were collected in January of 2025. This golf course tested from 4 different tees. The first tee, the phosphorus by Malik 3, was 76 parts per million. That is a suitable value, a relatively ample value, and I wouldn't typically recommend phosphorus if we have 76 parts per million. But then the tee number 7 was at 298, which is really high. Tee number 14 was at 199, which is also really high. And then tee 18 was at 5 parts per million, which is extremely low. Actually, 298 divided by 5 is almost 60 times. It's almost a 60 times difference to go from the 18th with only 5 parts per million to the 7th with 298 parts per million. And so there's different ways that we can calculate the average, because one of the things that I like to do when I'm preparing soil test reports is calculate the average value across a set of, across a zone. So I'll calculate the average for greens or average for fairways or average for tees. In this case, I want to calculate the average for tees. When we think about the soil test phosphorus, it can never be negative. It has a lower limit of 0. We can never have soil test phosphorus that is negative, but it's essentially unlimited how high it can be. And these type of data that are limited on the low end, but essentially unlimited on what they could be on the high end, you can get some pretty skewed values when you're calculating the average using the conventional mean, which is called the arithmetic mean, which means you take value 1 plus value 2 plus value 3 plus value 4. You take the sum of all of your values and you divide it by the number of values that you sum together. There's another way to calculate the average, another method called the geometric mean. And if you use the geometric mean, we get a value of 69 parts per million for this data, which is quite different. So 69 parts per million is lower, and it gives less weight to those really high values, and it makes the average closer to the lower values. And if you think about soil testing and how we're trying to prevent deficiency, we're less concerned about the really high levels than we are about the really low ones. It can be quite useful and safer to calculate the average using the geometric mean. So I wrote that using the geometric mean is safer and that it reduces the effect of nutrient hotspots in the data. Over the long run, we will end up recommending a little bit more fertilizer. And when you're using something like the MLSN guidelines, which are lower than the conventional guidelines that are really high, if you use the conventional guidelines that are really high, then you're going to end up applying a lot more fertilizer. When you start using the MLSN guidelines, it's useful to use something like the geometric mean to be a little bit safe and to make sure that we don't have hot spots in the data that are inflating our average nutrient values. I showed this also for potassium, and for potassium, the data are kind of normal on these same T's. So T1 was 86 parts per million, T7 was 113, T14 was 88, T18 was 99. Remember, T18 for phosphorus was 5 parts per million. Here, it was the second highest for potassium. So these ranged from 86 to 113, and the average values, if we calculate using the conventional method, it's 96.5 parts per million, and it's slightly lower using the geometric mean method. Now we get 95.9. So it's lower by 0.6 parts per million. That's an indistinguishable or negligible difference, but it is a little bit lower. When we get data that are really skewed, then the geometric mean is going to correct even more. It's going to be a larger difference. And if the data are relatively consistent from green to green or T to T or fairway to fairway, then the geometric mean is going to give a value that is almost the same as the arithmetic mean and just will be slightly lower. It's always going to be lower, but the degree of how far below the conventional mean method is depends on how skewed the data are. I also included an excerpt from the ATC soil report from a recent report in the appendix that has a section titled About This Report. That's Appendix A. Item 9 in that says, the average values shown in the charts and in the tables are, unless otherwise stated, calculated as the geometric mean rather than as the arithmetic mean. The geometric mean is slightly lower than the arithmetic mean. The geometric mean is particularly suitable for sets of soil test data to represent the central tendency of the test results when there is a real minimum value of 0. Remember, we can't have negative potassium in the soil, for example, but there is no such restriction on the upper boundary of a test result. And for soil pH, I don't do that. For soil pH, I usually show that as the median, but for average values for other elements, I am showing those as the geometric mean. So it's a much safer value with respect to potential low nutrient and high nutrient locations across a sampled area. When the soil test results are less variable, the geometric mean will be almost identical to the arithmetic mean. All right. Well, thank you so much for paying attention to all of that content from the 2 most recent blog posts. I am glad that some people pay attention to this and are interested in these type of technical issues. So thank you for watching, for listening. Do let me know if you have any questions, especially about the firmness, or if you have some comments, because that's something that I want to work on in explaining a little bit better. So I'll be interested to hear from you if you think that it's already understood well enough, or if you think that I have a particularly wrong-headed view about it. So that's enough. That's all for now. I'll sign off for ATC from Trong, Thailand. I'm Michael Woods. Bye-bye.